Hey guys, this is Shelby with the Roger Public Library. This week for Full Steam Ahead, we're going to be talking about solutions and chemical reactions and all that sort of fun stuff. So for the first experiment we're going to do, you're going to need a little bit of salt, table salt, and a little bit of sand. Both of these cups have about 3 tablespoons of them. So I'm going to pour the sand into this one cup. I'm going to pour the salt over here. And I'm going to add water to both. So this is a little bit messy, as you can see, so you might want to do it over like a kitchen sink or something like that. You might also want to have a grown-up help you heat up the water. Because this is hot water. The experiment works better with hot water, but not 100% necessary. So let's stir this one up. Okay, let's stir this one up as well. So you can already just visually see there's kind of a big difference in this jar, in 2 jars, and that difference is a lot more obvious. We shine a light on it. So we shine this light on here. The light goes through the jar pretty well. You can see it come out the other side. But when we put it on this jar, there's not an effect. You just see a shadow, and it gets stopped. So what's happening here is that we have a solution in this jar and we have a suspension in this jar. So a solution is when you dissolve a solid into a liquid. So the salt that we put in here combined with the water molecules. And so now they're just big molecules in that there's more atoms in each of them, but they're small enough that the light waves can just go around them. But the sand molecules in here haven't mixed in with the water molecules. And so the light waves that pass through the water get stuck and they get, and so it appears cloudy and not clear like this one. This is called the Tymdal Effect. This is also why some people have blue eyes, because the reason they have blue eyes has to do with when light gets scattered by particles like this, they turn a little bit more blue than they normally are. So remember, this is kind of a brownish color, and over here it's almost a gray. So it's gotten a little more blue when we put it in our eyes. And so the same effect with light getting scattered by particles is why some people have blue eyes. So just to be clear, when we're talking about table salt, its chemical name is sodium chloride. And the chemical name for sand, there's actually a couple different chemicals in sand, but the main one is silica. And I'm going to show you what the molecules look like. So this is a salt molecule. They're big squares stacked up together to form a kind of cube-like shape. And you can see that if you look at sand, it looks like a bunch of tiny cubes. And then this is what a silica molecule looks like. This is 1 nanometer, so that is 1/1000th of a meter for reference. So these are very, very small hexagons that are inside each little tiny grain of sand. So you probably noticed that both of those molecules are very regular. And actually, they're the same type of molecule, and they're both crystals. Crystals are a type of solid that have a very regular geometric pattern. So that's how these 2 molecules are similar. The difference in how the individual atoms in the molecules are connected together. So salt is an ionic compound. In ionic compounds, you have 2 or more atoms that are, one of the atoms is taking an electron from another atom. So we talked about before how electrons have a negative electric charge. So when one atom takes an electron from another, it becomes electrically negative. An atom that it took an electron from becomes electrically positive, so they stick together because of electricity. But in a covalent bond, the atoms are sharing electrons between them, and that means that the bonds are a lot stronger. So the bonds in salt are very weak, and the bonds in silica are very, very strong. So what does bond strength tell us exactly? Well, that's how much energy is needed to take apart the bond and let it dissolve into something, or just the atoms to separate from each other. Sometimes it's called a reaction. So if we dissolved silica in water, it would take a lot of energy from the environment, but not so the case with salt. Though actually salt does take a little bit of energy from the environment. And if you mix a bunch of salt and water together, you'd actually notice that the temperature would go down a little bit. So there's a difference here, the difference in degree, right? This takes a lot of energy, this takes a little bit of energy. But there's two other things that we need to know if something's gonna dissolve in water, if the chemical reaction will happen or not. And that is how free the molecules are to move around after we dissolve it. So remember, our molecules, very regular geometric patterns. Molecules don't like being stuck together like this, in one sense, in that if they like to move around a lot. And if they can get out of their crystal structures, they will. But sometimes there's just too much energy holding them together. The other thing that can affect a reaction like this is the temperature. So there's actually an equation that you can put the bond strength and the energy that's released and how free the molecules are and the temperature in. And what it tells you is that reactions that let molecules move around more happen better when the temperature is very hot. So this jar, this water is boiling, or it was boiling. It's about 100 degrees centigrade, something around that. You can't dissolve salt or sand in water at that temperature, but there is a temperature where you can dissolve sand in water, and that is 340 degrees Celsius. So if you know about Celsius, that's a little weird because at 100 degrees Celsius, water boils. So you can't dissolve sand in steam, but you can dissolve it in water, but only if the water is hotter than water is allowed to get, according to how we know water works. So we don't actually have the equipment to make sand dissolve in water here, but there are special industrial vats with very high pressures where water can get that hot, and these are used to grow quartz crystals that go in phones and watches and all sorts of things like that. Because sand is the same chemical as quartz. It's just a lot smaller. So that's dissolving, and that's how that works. And we can't make any cool quartz crystals today, but we can make cool borax crystals. So there are other chemicals besides sand that dissolve in water at hot temperatures. One of them is borax, or sodium borate. So here's some cool crystals I made. You can use these in jewelry and crafts and stuff like that. Another chemical that will dissolve in hot water, but not room temperature water very well, is sugar. If you add sugar to iced tea, it's not going to dissolve very well, but if you add it to hot tea, it will. And that's kind of the principle for how this works. So what you'll need is a pipe cleaner or a bit of wire. This is going to be our nucleation site. So this is where the crystals that dissolve or that separate from the water as it cools down are going to land on them and nucleate. And so the crystals are going to grow on the pipe cleaner until they get really big, just like these over here. So we're going to actually set this aside for a moment, and we're going to add the water to the jar. We don't need a lot. We don't need to fill it up to all the way to the top, which is why you want this string, so that it's hanging down enough. So it's not quite covered. We'll add a little bit more. Set this over to the side. Now we're gonna get borax. You can get this at the grocery store in the detergent aisle, like by the laundry detergent and stuff like that. And we're just gonna stir in the borax a little bit at a time. So it's cloudy right now because it takes a little bit for the borax to fully dissolve in the water. What you want to do is add enough that there's going to be a little bit that isn't dissolving. Okay, I think that should be about good. So this is our borax solution, it's super saturated right now. That means that there's more borax than will dissolve into water at room temperature. So as it cools down, the borax is going to nucleate out and form cool crystals. So we have this, we have our jar. And unfortunately, this process takes a little bit of time. You're going to want to cover this up with a towel and leave it somewhere where it's not going to get knocked over, and then come back to it the next day. And you should have something cool like these. And if you use your pipe cleaners, if you can get them arranged just right, you'll have even bigger crystals than these. Mine are kind of tiny as far as borax crystals go. You can also use a bigger container if you want to grow more than one crystal at once. Yeah, so that's our craft for today. I hope you guys had fun. I'll see you next time.